Regular Pepsi in first. We'll put it down in the water.
Whoa, that went right to the bottom.
Went right to the bottom, didn't it? That was the regular one. That was the one that's not the Diet Pepsi. Now we'll put the Diet Pepsi in.
Whoa, whoa, that one's floating.
Exactly.
Wow, that's cool.
Now, why? So what I'm going to do, I'm going to take this can that's been steaming, and now I'm going to put it down into ice water.
Whoa.
And did you hear that?
Yeah, that was loud.
And notice what happened to the can?
It like exploded.
It imploded.
Imploded?
Imploded, meaning it crumpled all the way in. Do you know what made it crumple in?
No. What?
The air pressure.
Wow.
The
air
air
pressure.
that is surrounding you. I'm going to put it in the flame and we're going to see what happens. We'll see if
Okay.
it...
No, whoa, oh. Whoa, look at that.
What happens?
It's not melting or catching on fire.
It's not melting or catching on fire. Now, how it does turn black, however, it doesn't melt and it doesn't catch on fire. How can that be?
Yeah, how did you do that, Mrs. V?
Act like we're going to pour it on the candle flame, and look what happens.
Whoa!
Yeah.
How'd that happen?
Yeah, the candle flame went out, didn't it, Maynard?
That's crazy.
Yeah, you
That's really cool.
Yeah, why do you think that flame went out, Maynard? So, Maynard, I want you to watch that air bubble and see what happens to the air bubble that is in that dropper when I squeeze. What happened to the air bubble?
Look at that.
Did you see that the air bubble got smaller?
Yeah, yeah.
And not only did the air bubble get smaller, but what'd the dropper do?
It sunk to the bottom.
Yeah, I wonder why it sunk to the bottom.
I don't know.
Maybe because it became more...
Dense?
Oh, good job. You're learning a lot from these science experiments.
Well, you're teaching me very well, Mrs. V.
You're exactly right. It became more dense. Try it and see?
Oh, I want to find out. Let's do it.
Okay, let's do it. Here we go.
Whoa, look at that.
And look at that. The coin went in the flask.
It
Now,
didn't
why?
go with the card at all.
Didn't go with the card at all.
Why is that?
What was the force that was acting on the coin?
Well, was it gravity?
It was gravity.
All right.
And so I have one of these wooden skewers, and I'm going to stick that in the balloon,
No.
and the balloon won't pop.
No way. I don't believe you, Mrs. V.
Well, I'm going to show you. The balloon is made of something called polymers.
Polymers?
Yeah, that's kind of a big word, isn't it?
Yeah.
Polymers are strands of molecules. Like if you imagine a whole lot of rubber bands just side by side by side, those would be strands, and then you put them all together and you get a balloon.
Oh, okay.
And what we're going to do, we're going to put the skewer between those strands, and they kind of seal around the skewer. So that's why the balloon doesn't lose its air.
That sounds like fun.
Yeah, so what we're going to do is to just use gentle pressure and kind of twist.
Oh, there it goes.
We got
it's in
the
there.
skewer in.
Wow, look at that. It goes right through.
And then we're going to stick it out. We're going to do the same thing up here and stick it out up here. We got to just work our way between the polymers. There we go.
Mrs. V, you were right. It does go all the way through.
And notice the balloon is not deflating.
Wow, that's so cool.
Yeah, because of the polymers.
We're looking for yellow.
We're looking for yellow. So let's watch and see what happens.
All right. Look at that. Look at that, Mrs. V. It's changing.
So what's happening, Maynard? We've got a pretty green solution. Shall we blow some more and let's see if we can get it a little bit more yellow?
Yeah, let's make an acid. Whoa. Oh yeah, look at the bottom of the cylinder.
Yeah, what's happening at the bottom?
They're floating, they're bouncing around.
Well, they're dancing.
Yeah, they're
Notice that they
dancing.
come up to the top and then they go back down, and then they come up to the top again and go back down. Well, so why do you think they go up and down? What do you think's happening?
I don't know. Is it because the bubbles are making them bounce up and down?
Sure. The bubbles of carbon dioxide collect around the raisins, and when the bubbles collect around the raisins, then that makes them less dense than the liquid, or they're kind of buoyed up, and so they go up to the top. And when they go up to the top, they release the carbon dioxide. They let go, the carbon dioxide leaves their surface, and then now there's nothing to buoy them up, and so they drop back down again.
Oh, okay.
We'll see what happens when we put a glowing splint into the test tube.
Okay.
So we'll light the splint, and then I want it to just be glowing, so I'm going to blow it out. I just want it to have a little bit of red on it,
Okay.
and we'll put it down in the test tube, and let's see what happens. Did you notice how it relit?
Yeah, that was way cool.
Yeah. The fact that it relit, that tells us that the gas that's present in there is
Oxygen.
oxygen. That's exactly right.
Wow, that's so cool, Mrs.
Yeah. So I think that's all today, and back to you, Stuart.
V. Bye, kids. We'll see you next time.